All right, so midterm review. Here's the worksheet that we're going to hand out. There may be some differences, but it should be pretty much the same. All right, so we look here. We say diagram as shown. Okay, so there's the picture, and we say that AB is parallel to ED. So I mark my diagram. Then it says AB is congruent to ED, so I mark my diagram as congruent. And I'm trying to prove that AC is congruent to CE. So here's what I'm trying to prove. I want this piece to be congruent to this piece. All right, so now it says given. We've got the diagram. AB parallel, that's given. Now, A and E are congruent. This is telling me specifically that angle A and angle E are congruent. Why would those two be congruent? Well, I'd call it alternate interior angles. Also, B and D are congruent. So I mark my diagram as such. Then it says AB is congruent to ED. That's given. Good. We've got those two triangles are congruent because of angle side angle. Then it says AC and CE are congruent. What always comes after a triangle congruent statement? CPCTC. Okay, we're done. So I move down. Problem number 2, find the missing step in the proof. So step 4 is what's missing. Oh my goodness, so much is going on here. We've got triangle JKL, and we've got the angle bisectors of all these pieces. Then we've got MR's perpendicular. We've got lots of perpendicular lines going everywhere. We're trying to prove that MS, here's MS, is congruent to MR. We're trying to prove those two are congruent. I'm not going to mark them that way yet because that's what I'm trying to get to. So we say that those two are, that's the given. We've got that part. Now we've got MP is equal to MR. MP is equal to MR, right over here. And that's from the angle bisector theorem. Then we've got MP is congruent to MS. Well, they're all congruent to each other. So I'm trying to say that MS and MR are congruent. That's because of the transitive property. You know, MP is congruent to MR, MR is congruent to MS. Sorry, MP, we take off the P's, and we're just left with MR is equal to MS. That's the transitive property. Number 3, which triangle would you construct to provide a counterexample to the following statement? Okay. All right. A scalene triangle cannot have a right angle. Which triangle would you construct to provide a counterexample? So we're looking for something that is true for the first part, but false for the second part. So this one doesn't have 90, so I don't care about that one. This one's got a 90. This one doesn't have a 90, so I don't care about that one. Remember, we look for the wrong answers. So now this one is a 90-degree triangle, but it has two same-sided sides. That makes this isosceles. So it's not scalene. I need a scalene triangle. Here's a scalene triangle. Each side length is different. And is it a right angle? Yes, it is. Therefore, C would be my correct answer. So for what is JK? Now notice here it says JK. Not just kidding. We're looking for something specific. Notice if it was JK with a line over it, that would be the segment JK. But since there's no line above it, we're looking for the distance of JK. So I use the distance formula. I use the square root of J. J is -1, 4. K is 3, -2. I'll write that better. 3, -2. So when I plug in my x's, I have -1 minus 3 squared plus 4 minus -2 squared. This becomes 6. This becomes 4. 4 squared and 6 squared, add them together, bring me down my square root. This becomes 16. This becomes 36. Not squared anymore, sorry. Undo those, that's my bad. We add them together, bring my square root. 36 plus 16 gives me 52, I believe. So my answer is the square root of 52. If it were multiple choice, I'd look for that. But I'm going to split this into be 2 times 26, I believe. Yep. And then 26 splits to be 2 times 13. So I have a pair of 2's that I can pull out. So my real answer is 2 root 13. There's my final answer right there, 2 root 13. So number 5, says, which best describes the following mathematical statement, and why? If two angles of one triangle are congruent to two angles of another triangle, then the remaining angle are also congruent. This is a definition, a postulate, a proposition, or a theorem. Okay, interesting. So a definition would be we're defining what something is. So what is a triangle, or what is a midpoint? Here we're not really defining anything. A postulate is something that is inherently true. It does not require any type of proof. Okay? A proposition, I don't think we've talked about that in this class thus far, but that's something that you're proposing to be true or not. A theorem is something that required multiple postulates in order to prove. So a postulate creates a theorem, or a couple of postulates create a theorem. But it looks like out of those four options, I would say it's a theorem. And my reason why is because multiple postulates were used to create this concept. That's just my opinion. I'm not even sure if I'm right. So that's what I would put. Number 6, what transformation have been made to figure 1 to result in figure 2? So what did I do here to get to here? Well, it appears as though if I were to reflect across the y-axis, this point would end up over here. This point would end up over here. Okay? And then I'd have this one would come over here, looks like. 3, oh, there we go. And this one would be over 4, right here. So if I just flipped it across the y-axis, it would look like that. But now, to get from this red dot here, I've got to come over to here. So I got to move it left one. So it looks like it's a reflect y-axis, and then a translation left 1 unit. There's a lot of different things you could do here. You could do a whole long list of transformations, up, down, left, right, but the minimum steps required would be a reflection and then a slide. Or you could say move right 1 position and then reflect. Either way works. So what is the purpose of this algorithm? Okay, given a right triangle, find the sum of the squares of its legs and then calculate the square root of the sum. What is the purpose of this algorithm? Is to find C, or find the length of the hypotenuse. We could put that. Let's put that. Find length of height. Okay, that's the purpose. Number 8. The object below is reflected across the x-axis, then translated 4 units left. Draw both new objects. All right, so I translate this. Let's see. It says reflected across the x-axis. So here's the x-axis. So I've got to go to here. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. And now I connect my dots. Looks kind of ugly, but that's okay. So now that's the reflected part done. Now it says translated 4 units to left. So now I move 4 left. 1, 2, 3, 4. Uh-oh. Go here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Everything just gets moved 4 over. 1, 2, 3, 4. Now my final answer looks like it's going to be here, 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 here. So those are my 2 new objects. I would have done them in multiple colors if I thought about it, but I didn't. So if x is a whole number, what is the smallest possible value for x? If x is a whole number, what is the smallest possible value for x? All right, so that means that we have to have x. Let's see, we do the longest side. Oh, geez. We do the 2 sides we're looking at. All right, so I've got 30, x plus 5, and x. And we know that x plus 5 has to equal 30. And we also know that, well, we could do this a lot of different ways. But this is going to be 2x plus 5 equals 30. Subtract 5, divide by 2, and I end up with 25 pounds. Okay, that was adding the two pieces together, right? We added the two shorts to get the long. Now, if we subtract the two shorts, we're going to have x minus x plus 5 equals 30, and that doesn't make any sense at all. So we're going to do 30 minus x minus 5 equals x. Okay, so we're going to subtract 30 and x plus 5. So notice I'm subtracting both of them. So this should be a 30 here. So we add x over. Either way, you're still going to get 25 fifths. Let me think about this for a second here. So yeah, we end up with 25 halves. That makes sense to me. So if it says a whole number, then the nearest whole number to this would either be 12, because half of 24, or it's going to be, that was weird, or it's going to be 13. I try both those out. 12 plus 17 makes 29, and 29 is smaller than 30, so that's not allowed. So I do 13. I do 13 and 18, and I end up with 31. Yeah, and 31's okay. So the smallest value of x is going to be 13. So now I say, what is the length of side ST? So here's my longest side. Now I think back to my cheat sheet, and I say this is supposed to be x, this is supposed to be 2x, and this is supposed to be x root 3. So since 4 and x are in the same position, I know that x equals 4. And I know that this over here is double that, so 8. So ST is 8. Number 11. Which formulas from the formula sheet can you use to determine the number of miles between two cities? Which formula or we're looking for the number of miles or the distance between two cities. So I would say the distance formula. There you go. Which conclusion can be drawn from the following statement? Goodness. If a triangle is a right triangle, then its two acute angles are complementary. Triangle ABC is a right triangle. So it says that triangle ABC is a 90-degree triangle. But this one up here says a triangle is a right triangle, then its two acute angles are complementary. And in our situation, our acute angles are A and C. That means that A and C have to add to be 90. This is true. Okay. There's our answer. A and C doesn't add to be 45 or 180 or 360. It just adds to be 90. That's the definition of complementary. Complementary. 13. Choose the most logical order for the following statement. If a figure is a triangle, then it's a polygon. If a figure has three sides, then it's a triangle. Oh, this is syllogism. I can recognize this from a mile away. So notice how triangle matches with triangle. That means that this one has to go before. Okay? So this has got to start us off. And then this one has polygon, and this one has polygon. So it's got to go K ends in triangle, and J starts with triangle. So KJ, and then J ends with polygon, and L starts with polygon. So it's going to be JKL. What is the difference between the area between the squares? Oh, the difference in the area. Great question. So I look here, I say this is P squared, right? P times P. This is 1/3 times 1/3 times P squared. So the 1/3 times 1/3 gives us 1/9. So the difference in the area is either 1/9 or 9 times as big. It depends on which way you go. But I'd say just 1/9 is easier for me. I'd just say it's 1/9. Okay, number 15. How much would the area of the rectangle below be increased if the width of the rectangle is enlarged by 9? Oh my goodness. So we're talking about area, and we're looking to increase it if the width of the rectangle is enlarged to 9 inches. So since 13 wouldn't be enlarged to get to 9 inches, we have to increase the 7 to be a 9. So originally we had 13 times 7, which is a 191. Now we're making it 13 times 9, which is going to make it 7 carried to 2, 117 looks like. This is a 7, by the way. So now the difference between these two is 91 minus 7. This gives me 6. And this gives me 2. So the difference would be 26 inches squared. That's the difference in the situation.